We're also very keen to introduce this tool, which we've found great success with. This simple tool allows us to take control of the high pressure pump by disconnecting it from the PCM, from the engine control module, and directly simulating a signal to the pressure control regulator, which is a mechanical hydraulic valve. In other words, the pressure is controlled on the exit route return circuit back to the tank. By introducing this tool directly to that valve, the pressure control regulator, we can, through a simple program within this tool, force the pump to work harder, generating more pressure, and from that we can determine if the pump has a potential to increase pressure. And what we're getting at here is the pump faulty, or is it a fault with another component? This helps us form this evaluation without the need to remove the high pressure pump. The last thing we want to do is to remove a component like a high pressure pump to find it's actually not responsible for the pressure loss. So later in the practical session we'll be demonstrating this tool. The type of system we're looking at is what we call CP3, which has two devices which can be tested by this tool: a low pressure volume valve and a high pressure regulating valve, and both of those can be tested with this tool. We can also test the pump blind by disconnecting completely and just having a look at the ability of this pump to generate a basic pressure purely from the return spring in the pressure control valve. So there's a number of tests we can do with this tool. You can also use this tool to test injectors. It's capable of being used as a trigger box to fire injectors and test the activity through the solenoid. So once again, this is a tool we rely on during our non-intrusive test procedure during the mechanical phase of testing. So this is going to come in with the back leakage test after serial communication. What I'd like to do is introduce the next concept of testing. I'd like to introduce this tool, which is provided by one of our partners, Darwin Diesels. This allows me to interface with the high pressure pump by interpreting or interrupting the signals from the PCM. It has essentially three functions: a simple gauge to measure pressure via the pressure sensor. It allows me to drive the pressure control solenoid, which in our case is in the rail, and or the volume control valve, which is on the priming side, the low pressure side of the high pressure pump. So we can control all these devices independently of the ECU and therefore prove the integrity of the high pressure pump. First of all, what I'd like to do is, well, I'm going to take my watch off for safety, is begin by doing a simple pressure test in the rail. Now the first test I'd like to do is simply a default value. The ECU looks for a certain default. It's 0.5 volt output from that sensor. Now we have at the moment three options within this menu. High pressure gauge, in other words, it becomes simply a pressure gauge, a pump testing tool, and an injector interface. For the moment I want to look at simple rail pressure. One of the first tests I always want to conduct is a proof test to see if the pressure sensor is actually active, because if it isn't, the ECU will not control the high pressure regulation. Key on engine off, we should have somewhere around 20 bar pressure. And that's about 0.5 volt in the pressure sensor. So by simply connecting the yellow cable into the pressure sensor, and I've pre-installed a simple acupuncture probe. An acupuncture probe is a thin needle which allows me to interface behind the pin without any damage to the wiring. I'd like to use this tool now as a simple pressure gauge. There's a couple of tests I want to conduct. One is a static key on engine off test to have a look at the it's a proof test so that the ECU can see the rail pressure sensor is active and there's a plausible signal back to the ECU. I've supported the vehicle with additional power because some of these tests involving cranking tests by nature are going to introduce voltage drops, and the voltage drop will probably mean the tool will drop out, in which case for cranking test it then becomes ineffective. So I've supported the vehicle with a DC power supply external from the vehicle battery. I'm going to enter pressure test, and we have a key on pressure now 16 bar, which is the sort of figure we're looking for a key on static test, somewhere around 16-20 bar. That proves to me there's about half a volt coming out of that sensor, which is a plausibility test conducted for the ECU. Once that sees that, the ECU then will control pressure regulation. That's the pressure regulating valve, and the volume valve will be in closed loop. So now I'm going to do a crank test. I anticipate 300 bar or more for an efficient pump. It's not just the figure we're looking at, it's the speed of increase. We need an instant 300 bar. The vehicle is capable of running probably from 200 bar upwards, but we need a good 300, 325 bar for a healthy pump and a very rapid response. Bear in mind this is dual control. We have volume control valve and we have pressure regulation. So if we can crank, please. Okay, 292 bar, quite satisfied with that. It took maybe a second and a half to build up to that pressure, but quite happy with that, very effective. We could actually do a blind test where we disconnect the pressure control regulator and we're looking for minimum 60 bar, anything up to about 100 bar, but somewhere within that range. So one more time cranking, please. Thank you. What that has tested is the integrity of the pressure regulator. Earlier on I explained that it's a fail-close valve under the influence of a spring, and that spring has the ability to retain pressure in the rail of around about 60 to 80 bar. That's working quite fine. So we've done two things. We've done a static test, nearly 20 bar. We've done a cranking test and achieved just short of 300 bar, and a blind test looking at the integrity or the ability of that valve to retain a certain amount of pressure. All of those tests have been done very promptly, very effectively, simply using this tool as a pressure gauge and no more. What I'd now like to do is introduce this tool to control this valve independently of the ECU. And we do that by applying a couple of simple adapters. We remove ECU control, attach this interface, which now connects to the tool via that socket. So this tool now has control of that regulator. But we need to put this dummy load in so that the ECU thinks there is still a component there, because if it saw an open circuit it would go into default. So we've in effect fooled the ECU. Right, we're now monitoring pressure. We have control of the pressure regulator. We can now exit that test and go on to the high pressure pump test. And we're now looking at CP3 as a system. And we have two options, a startup test or a tightness test. A tightness test is the ability of this system to retain pressure without leakage. Now, the pressure of course can leak from many components. The injectors, which we're going to do a back leakage test on soon, so we'll be going to test those. It could be a pressure leakage across the high pressure regulator. It could be a leakage from in the rail via the return circuit. We don't know where this leak may take place, so this is a tightness test to prove the system has hydraulic integrity. So let me select that first, and this should prevent us from running the engine. It says do not start motor. To activate, press start. So we now have a situation where before we had a cranking pressure of 300 bar. It's now telling us that we now have a theoretical pressure capability of 700 bar. So what we've done is we've doubled the pressure generation from the pump. So the point of this test is to prove the pump doesn't just build up 300 bar, but it can actually go to double that pressure because we now have direct control of the escape route, the pressure regulation. It's a proof test. I'd prefer to call it a proof test rather than tightness test. So we have target 700 bars and actual. So if you can crank the car, please. Thank you. There you see the results of the test. 700 bar target, 650 bar actual. So we've now proved, crank conditions only, we have almost 700 bar build up from that pump. That to me is a very, very sound, efficient pump. What this tool has actually done for us is interrupted control, normal control, from the ECU and the pressure regulator. It's given us a duty or control cycle of 45%, almost 50%. So we're driving that valve 50% closed, which should achieve 50% of the pressure capability of this system, which is 1600 bars. And we actually did achieve just shy of 700 bar. So we have a very effective pump, and we've proved that by a very simple connection using this tool, directly driving the pressure regulator and monitoring the rail pressure via the sensor. So we've actually disturbed very little in the system, but I'm able confidently to say now this pump is capable of building up 700 bars simply under a crank test with using this tool. So that's a tightness test, or a pump proof test. What I'd like to do now is to do a startup test which allows me to take over control of the pressure regulator independent of the PCM to prove that pressure can be effectively and quickly built up from the pump whilst the engine's running. Two things will happen. You'll see an increase in noise, diesel noise, because the actual rail pressure is being increased. So I'm going to increase the pressure and decrease the pressure by varying the duty to this solenoid independently of the ECU. So I'm going to engage startup test. It's asking me to put the adapter on, which we already have. We've obviously put an adapter between the tool and the valve, interrupting the ECU control. We've put a blind device in the circuit to fool the ECU. First thing we need to do is engage start. That allows us to run the engine. And you can see the default value, the duty value, is 22%. And I can now increase or decrease that by the up and down key, and that in turn then should modify the pressure. So we're at the default pressure, 12 bar in the rail. And start up, please. We have around 300 bar pressure, but by increasing the duty, you can see the pressure is being increased. And decrease. You notice on the decreased pressure the engine goes quieter, and you can see it's struggling now to run. We're down to 250 bar, so let's increase the pressure again. 300, 400, and you can see that we can modify the pressure. And also at the same time what's taking place here is the volume valve is looking at this. This system is still in a form of closed loop control. I'm playing about with this valve independent of the ECU, and the ECU is seeing that the rail pressure is not within its anticipated map, so it's driving the volume valve, trying to fight me. So as I drop pressure, it will increase the volume to build up and restore the pressure, and if I increase pressure, there you see the rise 400 bar, and immediately the volume control valve then tries to counteract me. Switch off, please, June. And start up again, please. What I've done now is remove the volume valve. This should now give me total control of the pressure control regulator. So I'm going to increase the 22% duty, and we should see the rail pressure then rise from 340 bar 420, 440, 490, and we've hit a buffer. We've now come to the limit. The system's now going to default. But you've seen there now, I've got direct control. We've built up pressure very quickly, very effectively. We've defeated the regulation valve in volume, which is a normally fail open valve, so full volume going to the priming side of the pump, and we've taken over control now of the pressure regulator. Let me just reduce that, and if you fire up again please. Once again I can remove, lower pressure or increase pressure, and we'll soon hit this default buffer, 400, 500 bar, system closed down. So we've tested several things during this short duration. The ability to drive that valve and increase pressure, the ability to see the closed loop control of the volume valve, the ECU's trying to fix the problem, and you've seen the ECU's response to an aggressive pressure in the rail, and it's gone into limp home and shut the engine down to protect the engine. So by using this tool, we've been able to achieve several tests which proved to me the components are working, the ECU's response is working, and in particular the high pressure pump is actually capable of increasing pressure very quickly, very effectively. That's the purpose of that tool. It's to determine if the high pressure pump is in good order before we embark upon removing it for further testing or replacement. What I'd like to do now is a cylinder injector back leakage test. So once again, just going to close the filming down just briefly whilst we set up the next set of tools, and then we'll do some cylinder leakage testing.